And more importantly, why that also matters is one of the problems that we've had in information security to date is it's a less mature field than some of the things that Michael has been dealing with in the past. And I'll talk a little bit about that, but there's a lot of lessons to be learned in information security that we can glean from things like fraud analytics, from things like physical security and others. I think we're back on track for present display.
Are we good to go?
We're going.
Cool.
We're live. I got it.
So, starting absolutely from scratch, I did the thing that any grad student would do, and I went through all these academic databases, looking for articles and being like, so how do I help businesses prioritize vulnerabilities? What are the trends? What do the statistics look like? And that was a pretty fruitless search. That led me to find a whole bunch of things saying something like, vulnerabilities are, the rate of vulnerability disclosure is increasing, or this type of attacker does this. And the trend that I see in academic papers is one of two things. Either people are conceptualizing an attacker in a way that they think works. So somebody's saying like, APT1 does these things. Let me look at some trends and vulnerabilities from what I think the attacker does. But that prescription is kind of a priori and isn't really based on data. Or people are talking about the rate of vulnerability disclosure, which I take issue with for an entirely different reason. That's a definitional analysis, not an analysis of things you actually have to fix. So the next place I went is InfoSec blogs. And I read a bunch of the stuff that people are talking about, figured out that the place to go is threat reports, it's vulnerability intelligence reports from the biggest vendors. Of course, the problem with those is that those are specific to their customers, their customer demographics vary, like you can't nail down a population. I wasn't sure what to do with that, nor did I have the raw data itself. So I went to Twitter and started following a bunch of probably the people in this room to figure out what people are talking about. And that led me to the kind of beginning of this talk, and there are these definitions that we have for what a vulnerability is. They come from MITRE and they come from OSVDB. NIST ranks them with a CVSS score, and the next step that I did is I just went through the message boards of how these things were created and took a look at it. And the picture was not so good. I wrote a blog post a couple of months ago about data fundamentalism, and the idea is that data is created by humans, and the way that the things that we record, or the definitions that we create for this data, is creation, and these things have biases in them. But we often think that because we have, this percentage increase, that's a fact in the known world. Here are the problems with that. The first problem is that the vulnerability data that we have today is created by an organization that has limited resources. And so in order to push out all the vulns that come to them, they do a few things. They choose the things that are easiest to push out, because a 5-chain vulnerability that uses 8 CVEs is going to take a lot of time, and it's a lot easier to release 10 that take 10 seconds to write up or 10 minutes to write up. They prioritize vulnerabilities based on what they think matters. So some of these things actually do matter. Microsoft phones always make it into the NVD definitions. Some of these things are things you would like to see but don't see. So maybe you're using a software that's not on the priority list, and so you don't get a lot of the vulnerabilities that are submitted exist, but MITRE or NVD might not rank them. And the next problem that I found, and you guys should go see the Jericho and Sushi Dude talk at Black Hat, and also Luca Lati, who is a guy from Italy who does a lot of this type of analysis, is that vulnerability statistics and the ways that we conceptualize trends generally are done from the definitional level. And I think this is the biggest problem that I found in information security, is that people take these definitions to be the same as instances of the actual vulnerabilities. And there's a big gap between the two. So if you look at the English dictionary, you would think that people don't use the word fuck a lot because it only comes up once. However, it's all over the place in actual usage. And that's actually the main flaw in what we're going to try to address today. It's that we're going to look at the usage of vulnerabilities or the occurrences of them rather than their particular definitions. And the type of analysis that we do has been done before. Luca Lati has done this, and that image is actually from his talk. And he looks at NVD, he looks at the definitions, and he tries to figure out, what can you say by looking at highly ranked CVSS definitions and like the sympathetic threat reports. So 87% of the things being attacked are high scored, but so is like half of NVD. And that doesn't really tell you much if you're looking at the high scored things and trying to remediate them. That analysis is all good and fine. I think it's a lot better done when you look at actual vulnerabilities rather than definitions. So this is a few examples of the things that I found that are wrong. They come from, the highest of sources. Vulnerabilities have not declined 26% since 2006. I think that paper was in 2010. The rate of disclosure might have declined, and the rate of disclosure of definitions might have declined, but people are just as insecure as they were back then. And, the total number of vulnerabilities is a really misleading statement. People don't actually have those numbers. The total number of vulnerabilities is something that we can one day hope to see 1%. So we have some percent of that, and that's how we're going to structure the rest of this talk. All these things that are definitional don't really matter. What matters is actual vulnerabilities on actual systems. And of course, the definitions to define them should be there, but they're not what matters for statistics. So the framework that I talked about earlier comes out of a few places. I did a bunch of work in game theory, and when I started thinking about security first, I thought of San Francisco bicycle thieves, and I thought about counterterrorism. These things are, the attacker doesn't really have much cost. It's really hard to catch them. If there's a false positive or there's a false negative, that doesn't really matter to the attacker. There's a wide array of targets, and it's pretty profitable. It seems to be an analogous concept. So I took a look at the way that people do this right now. And these fields are really mature. Like bike theft, people are pretty good at not getting their bikes stolen. Like the shim bet prevents 99% of terrorist attacks that are being planned. What do they do? And keep in mind, this is just one model. There are many models of, a game theoretic attacker-defender strategy. But this is the one we'll use, and many other ones can be used. I think this one's useful. So there are threat actors, and we all know about that. There's the script kiddie, there's APT1, there's different types of them. But what matters is that you constantly update your definitions of these things as a result of the other ones. Then there are possible strategies. The bike thieves, they can go after the $5,000 bikes, or they can steal a bunch of the ones that aren't locked up that cost $100. This is the vulnerability definition that people do analysis on. And that's wrong. There's a lot of other steps to it. You take the definitions and you look at actual ongoing attacks. So in this casino, those definitions of vulnerabilities would be something like, the people on our blacklist have previously done this. We need to prevent against it. But then we take a look at what's actually happening. And I'm going to skip ahead too far, but that's okay. I take a look at what's actually happening, and they have cameras monitoring in real time. They're trying to figure out whether something's happening. So we have, SIEM networks that try to do that, but it's not correlated to those definitions. Then once you have that, once you have your threat actors, your definitions, and the actual attacks that are happening, you want to take a look at the system topology. And by this, I don't mean whether this laptop is connected to this network. What I mean rather is which vulnerabilities are on which assets, not the definitions of those vulnerabilities. That's something that we have a lot of experience with at Risk IO. And you want to update those actors, those possible tactical strategies, and those actual attacks based on where you fail. So everybody looks at the DBIR at, like once a year or twice a year and decides that these are the things that matter. But in reality, you want to be looking at successful breaches that are happening in real time, much like you don't want to be looking at the definitions of, like SQL injection is 8% of known breaches. You want to be looking at, in the past week, we've seen 20 SQL injections, and we have a couple of them on our assets. So in counterterrorism, they do this pretty well. I think that analogy is really clear. They've been doing it for about 50 years. They have things that fit into these categories pretty well, and they have these processes that update each other. Most importantly, what they have is they have successful attacks, and that's how they've learned most of their things. They also, unlike us, have close calls and near misses. So that allows them to know kind of the in-between probabilities. So if an attack is a near miss, you know that that vulnerability is going to be targeted, and people haven't been breached on it, but maybe you'll be the first one to be breached on it because it's been a near miss for the past half a year and it's gotten more advanced. The most simple analogy of this framework is in sports. People do scouting reports to figure out opposing teams and players. They look at game tape to realize possible strategies. Can that kid actually dunk or not? Then they look at gameplay and they figure out, like, oh crap, that little kid on the bench is really good and he can shoot a three like none other. And based on that, they update their roster. They think, like, we should defend against these people. You need to be running faster. You should jump higher, so train your jumping because you can't defend that kid that's dunking. And the point that I want to drive home here is that sports teams learn a lot from losing. You hear like motivational speeches in every movie about them doing this. They learn from losing because this allows them to update what other teams can do against them and how they're performing. It's a measure of your performance, and it's also a measure of those threat actors and potential actions. What's missing from the slide is actually that they also learn a lot from near misses. So when the Bulls lose to the Miami Heat by 2, or win against the Miami Heat by 2 points, that's not a win. That's a near miss. And what that means is that you need to update your strategies in order to make that point differential higher so that you're actually safe. And this is something we fail to do in security often. So what does InfoSec actually look like? And this is, all these things exist in security. It's just that they're pretty disparate. People scan their assets. They want to scan more assets to understand where the vulnerabilities are. And then we have a bunch of people who are doing some good work on breach reporting, some people who are doing good work on threat intel, some people who are looking at specific parts of malware and realizing what it does. But what we really want to know is how that malware got in there in the first place. What's the vulnerability attack path that it took? Or from breaches, how did those breaches occur? What CVE were you breached on? Because then that allows you to prioritize the things that actually matter instead of fixing all of your vulnerabilities. So, I guess I already said this. Anyways, the point to drive home from this one is that vulnerability definitions are the possible strategies that are being taken. They are by no means the successful attacks. And the gap between that is a couple of levels of analysis that are missing. And what's going to fix that gap is looking at actual distributions of actual vulnerabilities. The things that you want to be remediating are not necessarily all of the vulnerability definitions. They're rather the things that are being attacked to reduce your chance of being breached. And so all this data exists. It's just that people aren't aggregating it together, and I'm not going to pretend like we can do that either. Here's what we have. We have a lot of assets with a lot of vulnerabilities that we scan from our clients, and we have data about successful attacks and what CVEs were taken and breached. So the rest of this talk, we're about to get to the meat because the framework is over. We'll talk about what the status quo looks like based on those 2 parts of this framework that we have, and why the status quo is pretty shitty and how we think you can fix it. For future work, all those things that are listed on the right-hand side, the left-hand side of that slide are things that should be integrated into it. Here's what we have. We have 23 million vulnerabilities sitting across 1 million assets, around 9,500 companies, and 22 different scanners feeding this data in: static scanners, dynamic scanners, Nmap, whatever. And this is the data set that we'll use to do the kind of statistical analysis that people are using a data set of 55,000 vulnerability definitions. I think it shows that the things that we glean from definitions are often very wrong. So what can we tell you about the status quo? Things that you can say from live data that you can't say from definitional data is the performance of your team or those scanners. So for scanner performance, we can tell you about duplication. How often do 2 scanners find the same thing? Duplication is problematic because if you can't dedupe the thing, you're wasting resources and it's expensive, and maybe you bought a scanner that you shouldn't have. We can talk about vulnerability density so that you know, maybe you're not scanning all your assets, but you can estimate what it looks like on the rest of your assets. And we can talk about how people are performing because we know when they close a vulnerability and when they don't. So, about 87% of vulnerabilities are found just by 1 scanner. Keep in mind that this might be because our clients only have 1 scanner, but 12% are found by more than 1 scanner. And this is kind of problematic because if those aren't deduplicated, people could be fixing a vulnerability that's already fixed. You could also think that you are in a bigger position of risk than you actually are. You could be prioritizing assets that are actually pretty safe. So to use this data in a meaningful way, the counts on the left-hand side are how many are duplicated out of the 23 million. To use this data in a meaningful way, I'll have Ed tell you what somebody who knows about security would do with it.
So that's a lot to take in, but ultimately the duplication thing does matter. And what we're looking at from a duplication standpoint and what we've looked at across our data set, actually that 12.5% is a little bit misleading because we're aggregating across our scanner coverage different classes of scanners, right? You could have a network scanner, you could have a dynamic application scanner, a static analysis tool, all these different things. Obviously, a static analysis tool and a network security scanner are never going to find the same vulnerability, or almost never find the same vulnerability. So that 12, if you just broke it down by class and we looked at just network scanners, that 12.5% is actually even higher. But why does that matter? So taking some lessons back from my previous employments, what we're looking at is about scanner coverage, and not asset scanner coverage. That's a different problem, and not data that we have readily available to analyze, but more of vulnerability coverage. As Michael was talking about earlier, he talked a lot about the problems of vulnerability definitions, right? Everybody's basing their decisions based on what makes it into a CVE database, what makes it into the National Vulnerability Database, but that isn't encompassing of all vulnerabilities. And you want to be able to measure false positives, false negatives, that sort of thing. And you can do that by having these multiple scanners. But what we did basically determine by looking at this data, what I see when I'm looking at this chart is essentially you get to the point where the lack of return diminishes greatly after 2 scanners. So if you've got 2 network security scanners, maybe one's external, maybe one's internal, maybe they're both in the same location, whatever, you're going to get good coverage in terms of finding at least vulnerability definitions or being able to detect those. But once you get into 3, 4 of the same type of class, it becomes much more expense than it's really worthwhile. But another piece to consider here is vulnerability density. So Michael pulled these numbers for us, and I took a look at these, and the first thing that I looked at over on the right-hand side, I said, none of this is a surprise. This is actually, very common and something that I've seen all the time. But essentially the top 3, where the greatest amount of vulnerability density exists, meaning number of vulnerabilities on a given asset, is much higher than the bottom 2. And the top 3 really encompass the network and infrastructure scanners, right? Versus the file-based stuff, which is all static analysis tools, your Fortifys, Vericodes, and then URL, which is your dynamic application scanners. It goes way down the list. But there are some things here that are really interesting from a remediation standpoint. First of all, if you can do duplication or deduplication between a file and a URL, meaning if I can take a static analysis tool and I can take a dynamic application scanner and I can correlate some of those results together, you tend to get a lot more false positives with the static analysis tools. You tend to get a lot more false negatives in general with the dynamic application scanner. Between combining the 2 of those together, sometimes you can weed out false positives and false negatives. The other thing is more about remediation. So maybe my vulnerability density is much, much greater when it comes to the infrastructure side of the house, but remediation tends to also be much easier. Sorry, go ahead.
Yeah, so that was kind of what we could glean about the status quo of the networks that we have scanned and the data that we have. What's more interesting for us to figure out is how are people doing at remediation. And taking a look at just CVSS score breakdowns, you can see the bottom line is average time to close by severity. The trend is pretty sharply down. It doesn't look so sharp because the scale's off, but as the CVSS score increases, that's where people are quicker to remediate it, which to me indicates that people are using CVSS as a guide for remediation. Also, what's interesting about that is that the gap between how fast people are remediating things and the oldest vulnerabilities that exist in their environments is pretty huge. That's days on the left-hand side.
Question in the back.
Yeah, I was just curious if the data you have at all correlates with the flawless half-life of vulnerability data.
Yes, in some ways it very much does, but even more so, I would say, and Michael will show this later, these tend to line up almost directly with CVSS scoring, right? So
actually, that's your slide. Let's take it now.
You bet. So when you take a look at the data and the 2 charts that Michael was showing earlier, one is essentially the oldest vulnerabilities within your system. The other is more on the average rate of closure in terms of number of days. And then the bottom is the distribution essentially of taking the National Vulnerability Database and taking all of their CVSS scores and seeing where they fall. And the curve on the bottom and the curve on the very top are almost identical, meaning people are very much making their decisions around remediation based on CVSS. Now that is going to be problematic, which Michael will talk about in a minute as to why, but it turns out to not be a surprise.
So I follow people in this room on Twitter, and I realize that most of us can bash on CVSS all we like, and it's not a good guide for remediation. But what's more interesting to me is how can we actually prove that CVSS isn't working? And so that's why we talked about this entire framework in the first place. This is kind of the meat of the thing and the stuff that really matters. We have 1.5 million vulnerabilities related to live breaches recorded over the past 2 months. This comes from the Open Threat Exchange. And first let's talk about what's missing here, because I'm going to lay down some revelations. But what's missing here are two things. The first is the impact of those breaches. We don't know whether somebody breached a vulnerability and nothing happens as a result. So that probably occurs in most of these, but it's still important to know that you've been breached on it because chains occur, because being breached in the first place is what you're trying to remediate. And the second thing that's missing is the intermediary step. We don't know, this is 1.5 million breaches, but if that's 1.5 million breaches out of 2 million attacks, this changes the probabilities of you being breached on a vulnerability. If it's out of 50 million attacks, that changes it as well. But, we don't have the data, so let's not look at it. Here's the best analogy to what the rest of this talk will be like. Think of it as a pre-flop for a Texas hold'em hand. We know that you've got 2 cards. We know the probability of you winning with those 2 cards, and that's about it. We don't know what's going to happen on the turn. We don't know how other players will react. But we know that in order to win, you need some good cards, and we know what those cards look like.
And just to add to that, this is breach data in terms of successful exploits. Another caveat that we don't know is we don't know impact, right? So we don't know that this was a chain of 1 of 5 vulnerabilities, of which the first one was successfully exploited and the last 4 were not. We don't know if this was something that ultimately ended up in a very large-scale breach, or it was, dropping malware on a lunch server. We have no concept of that whatsoever.
Right. Let's actually get it all off our chests. The other thing that you need to keep in mind is that these breaches come from a data set that is disparate from the vulnerability data set. So it's not like these are breaches that happen to our customers. These are just breaches happening. And the population sizes of the population sets are just different. So, you can make many arguments about but no, this population is different from this one, and your correlation doesn't matter. To that I say, whatever. This is all the data we have. And, when you're reaching the tens of millions, you might as well take a look at it, because it probably needs. So, let's talk about CVSS and remediation and why it actually sucks. If you look at the oldest breach vulnerability by severity and you take a look at CVSS, the trend looks pretty sweet, right? The 9s and 10s or less, because people are remediating those. But if you look at the oldest breached vulnerability by CVSS, the graph is just crazy and makes no sense, right? The 4s and 5s are getting breached, and those things are 3 years old, and you probably aren't paying any attention to them anymore, but you should be, because those 4s and 5s are how people are getting into your systems. There's a huge dip around 6, even though there's a whole lot of 6s in NVD, and yeah, there are some 9 and 10s, okay, yeah. The things that really matter, they can flag in NVD. So what this tells you is the way that we conceptualize the whole set of vulnerabilities that we have and rank them by CVSS only matters in so much as breaches are occurring in it. And the linear progression from 1 to 10 of CVSS just does not exist when you look at breaches. What does exist is that the counts of the 9 and the 10s are really high. And that's probably because, I don't know much about how you actually exploit something. But I'm guessing that the exploits that people are firing off on their botnets are the ones that are 9 and 10 CVSS things. And that's actually why they're getting scored 9 and 10s, because somebody saw it in the wild, or it's not a proof of concept, it's an actual exploit. That said, there are still 25,000 4s that were breached on that we should care about. So the rest of this talk, I'm going to talk about probabilities. And they don't mean anything when you have 2 different populations. But in terms of rank ordering things, you can use it as kind of a guide. So CVSS, how good is it? If you look at a random vulnerability, just throw a dart at all the vulnerabilities in your network. And by that I mean throw a dart at 23 million vulnerabilities that we're looking at. The probability that one of those has had a breach occur in the past 2 months is 1.98%. So I apologize for the precision. The precision matters in terms of just comparing it to other things. It actually means nothing. So say 2%. That's if you were just trying to patch everything to remediate everything, and you felt really good about getting 10 vulns solved in the past week, the chance that you're actually preventing a breach for each one of those is 2%. But we use CVSS. We know which ones are important. here's what it looks like if you only look at the population sets of CVSS breakdowns. If you're looking at CVSS 10, you're doing okay. 3.48% chance, so about twice as good as throwing a dart at a board. If you're looking at CVSS 9, and this is misleading because I did a group by and rounded it off, it's actually, at CVSS 9.5, you're doing better than random. At CVSS 9, no longer. And if you look lower, using CVSS as a guide is worse than just randomly picking vulnerabilities to remediate. So it's really sweet to bash on CVSS, and now we actually have some proof that it doesn't work. It should really just be a 10 or a nothing at this point. But what's more interesting is the alternative to that and what strategies actually work. And with that, let's do this.
So to take a step back, there was a smart guy I know named Alex Hutton, who may or may not be sitting in the back of the room right now, who coined a term called the security Mendoza line several years back at this point. But essentially, and I will quote Alex rather than since he is in the room, wouldn't it be nice if we had something that helped us divide who we considered an amateur and who we considered a professional when it comes to security? So for those of you not familiar with Mario Mendoza, baseball player, Pirates, 1970s, who really actually played for a number of different teams in the majors for a number of different years. And the amazing thing about him is that he sucked at batting and played in the major leagues for years. And that is because of his remarkable fielding, although some debate his range. And he was able to do that while batting a lifetime average of around 200, or 2 hits out of every 10 at-bats, which sucks for someone who's at that level. And they later ended up coining that the Mendoza line, meaning if you are hitting below the Mendoza line, or if you're hitting below 200, there's a good chance you're going to get sent down to the minors where the quote-unquote amateurs play, even though they're actually professionals that get paid as well. So the security Mendoza line was, where is this, and Alex, feel free to correct me since you're actually in the room. But essentially, where is that line in security? Where can we state that we are professionals versus amateurs? What is the baseline that we need to be doing as security professionals? Later, Josh Corman comes along and expands on that a bit in something called H.D. Moore's Law, which I'm not sure who's familiar with H.D. Moore's Law. Obviously, probably everyone in the room is familiar with Moore's Law. I'm also going to assume everybody in the room probably knows who H.D. Moore is, co-founder of Metasploit. But essentially, it's became this line of the rate, I'll quote him as well, casual attacker prowess grows at the rate of Metasploit. So Metasploit is a really great tool, and a lot of really good people use Metasploit, and a lot of very untalented people can also use Metasploit because it's so damn easy to use. And there's these Metasploit modules in here, which are just exploit modules, which essentially mean that you can point, click, and shoot and attack and exploit a particular vulnerability. It's become easy. It's become table stakes, really, for us as security professionals of that line that we need to protect against. Do we have vulnerabilities that are in the Metasploit framework? The chances are, of an organization of any size at all, the answer is yes. And it's actually, while this is a very basic premise that you need to be able to protect against your lowest attacker, it's much, much harder to do in the real world.
So think about that policy for remediation instead of CVSS as a policy. It tells you that there are certain types of attacks that you should be remediating, and it fits really nicely into the framework that we started this with. It tells you what types of attackers you have, what you should be protecting against, and the baseline is script kiddies. It also tells you what types of attacks they actually undertake, so what CVEs are in Metasploit. It tells you what's happening out there, which ones are being breached via Metasploit, and that allows you to do prioritization. So this one is kind of the money slide, and it tells you how much better a policy of remediating Metasploits and exploits does than a CVSS 10 policy, which is the only thing that does better than random in CVSS in the first place. So if you're looking at exploit DB and you take a look at all the exploits in there, and you at random pick a vulnerability that's an exploit DB, and you remediate that one, the chances are that, the chance is 12% about it, that you're fixing something that somebody has been breached on in the past 2 months. If you take a look at Metasploit, that chance goes up to 25%, is that right? Yeah, 25. And if you look at the intersection of the two, which ends up being 697 CVE identifiers, and you pick one of those at random that's on your network, you have about a 30% chance of fixing something that somebody's been breached on. That is 10 times better than the best that CVSS can do. And that is about 15 times better than picking one at random. So the next time that somebody tells you you need to fix a vulnerability, you need to decide which one. If you're picking one at random, it's 2%. If you're picking a CVSS 10, it's like 3%. But if you just look around Metasploit and see that you have one, 30% chance you'll be breached on it in the next couple of months. That's it.
And with that, we'll take questions. Going once. I have T-shirts if anybody wants to ask a really good question.
Well, I have a question.
Am I allowed to throw?
Given what we know now, is there any?
Of course, the guy in the back of the room.
Why not just patch everything?
Why not just patch everything? Who here in this room patches everything? Well, for one, great question.
So
Thank you, David.
I actually looked at that data, and we decided not to show it today, mostly because our patch data, like the number of patches that are out there, isn't so good. But the thing about patching is that people release patches for things that people aren't exploiting. So if you have the choice, patching is really easy, but if you have the choice of patching 10 vulnerabilities that no one's exploiting, or spending the money on a code rewrite that'll fix a Metasploit vuln, you're probably better off fixing the Metasploit.
Right, and to that point.
I was thinking just commercially released patches, or patches released by someone outside your organization.
It goes far beyond that, though. When you start patching things, especially if you're a developer, you start breaking things. You can't just arbitrarily go push patches out to a bunch of boxes. All the applications that run on top of it as well. You gotta go through this process that you go through, and you don't patch everything at once, because otherwise, if something breaks, you don't know which patch broke it.
Yeah, and it's not only that, but I mean, to Michael's point, that there's only a certain subset of that data that is patchable in the first place.
That's fair.
So regardless of how much you patch, and maybe you patch everything, if you looked at the money slide of Michael's, in terms of what's in exploit DB plus the intersection of the Metasploit framework, a large chunk of that, and we don't have the data unfortunately here to display, but a large chunk of that is not patchable, or is something else, right? So it's more than just patching, although that said, there's so few organizations that I've met that actually are patching everything.
So at a previous organization that I worked at, we took the attitude that we would just sequentially push every patch from Microsoft and Sun and IBM to our servers.
Yep.
We should pump them out because we would do a test install. If it didn't blue screen, it was good to go. We'd rather break the network in a way that we understood than wait for someone to break it for us.
I don't disagree with that, but so when you say patch everything, though, I also see, yeah, we patch everything, and they come back and we patch all of our Red Hat boxes and we patch all of our Microsoft stuff, but what about the 35 different apps that you've deployed on all the desktops and everything else? And that's where it falls over. Right?
And that's also expensive, right? So this type of analysis lets you make your next decision of the next vuln you fix. It doesn't let you make a policy decision about like where you spend your money nonstop. So even given that, say you can't patch everything because you've got only $10 in your pocket, the thing that you should patch should have a Metasploit.
Right. Could be Flash and Java.
Yep.
Also, we didn't include that trending data, but Flash and Java is definitely part of that.
That's all it is.
Although it's not easy to use in bulk, Brian and I have been working with HD to kind of cross-reference exploit DB and Metasploit modules, the CVE, and if you're looking for a way to prioritize, you can go in there either by exploit or vulnerability, and you'll see all the cross-reference of how all of those fit together. And unfortunately, like I said, it's not set up for doing bulk. You can't take some scanner output run through there and help you prioritize. But if you want to do the research and trying to make a decision on which ones to do, like you're suggesting here, that web page that's off of Rapid7 can be used to kind of help you, because it does contain that data on which ones are intersecting and all that kind of.
Yeah.
I'm sorry. So you work for Rapid7?
Yeah.
Okay. So you have something that actually does this sort of thing for people, but you can't do it in bulk?
Correct. I mean, the web page we have, you can do a full text search by an exploit name. You search for Java, it'll dump out all the Java exploits, all the vulnerabilities, the exploits that might take care of those, and you can get that information there. You know, it's updated once a day. Every Metasploit build, every Nexpose build pulls the CVE and the OSD, or not OSD, exploit DB every day, and it's updated every morning.
So an important point here is, yes, this is great in the fact that it's way better than this, but this is still only less than 30%, right? So that means we are still underwater and running on a treadmill that's going much faster than us. We didn't talk too much about the rate of discovery versus the rate of close, but it's not a pretty picture. But also the attack data that we've analyzed over the last 2 months. There's shifts and trends in that as well, right? So being in Metasploit plus exploit DB is good. It's better if I can tell some of the trends that are coming out of the actual real world attack traffic as well, so that I can start to say things like, well, yes, that was important, but that was really getting hit on a lot last year. And this month, it seems to be this, or this week, it seems to be this.
So here's an example, like you've got a Flash vulnerability that's an exploit in Metasploit, and you know that a lot of people are deploying Flash, so chances are there's like 10 botnets hitting it. That's the kind of stuff that makes you be 100% successful at predicting breaches. Before we continue though, one thing you need to realize is that these are success probabilities, right? So if you take that policy on, we also need to think about failure probabilities. So if you're patching a Metasploit, what's the chance that, or you're fixing a Metasploit vulnerability, what's the chance that you're just doing nothing and fixing something that isn't actually being breached on? So those kind of sensitivity analysis is something that needs to be done as well to realize if you take on that policy, how good is it to be 30% more successful. But again, to that I say if you're 15 times better than CVSS, then whatever, just do it.
Have you broken this data out at all by application type or OS or device? I mean, if I'm not running PHP, does that all of a sudden decrease this down to almost nothing?
So we have the data.
We don't care about PHP, but that's the first step.
So to that point, though, he's kind of being half sarcastic, but when we talked about the vulnerability definitions at the very beginning, that's part of the problem, right? So when you look at everything that's in a national vulnerability database, you suffer from selection bias. There's only so many people at MITRE that can enter this data in, so they're going to say, okay, I'm going to focus on the Microsoft and then things like that, and oh, this is PHP, I'm throwing it out. Doesn't mean it doesn't exist as a vulnerability. They don't have the resources to publish it into the National Vulnerability Database. Doesn't mean it's not real.
On that, something really interesting to watch is, as of the past 2 weeks, I've been monitoring the MITRE feeds, and a lot of them are just exploding with PHP vulnerabilities, which means that either they have more resources or the prioritization is changing. But if you think about it, the types of vulnerabilities changing in the definitions, if you look at some of those reports that I call bullshit, they'll start to change and maybe the vulnerabilities are actually increasing, but this probably won't change.
Did you look at the same data so that you're looking at the time of release, public release of the vulnerability?
So the graphs a while back were oldest vulnerability by CVSS severity, right? You remember the really big gap between the two curves? That was the oldest vulnerability by release, and then the next slide where I was like, CVSS is bullshit, the crazy graph that goes all over the place. That's the age of breached vulnerabilities by disclosure date, and it's all over the place because there's botnets that are hitting CV 1999 stuff all the time.
I was speaking specifically of this.
The Metasploit data?
Yeah, Metasploit and the breakdown of the CV and exploit DB.
So, no, I haven't done that, but off the top of my head, I can tell you that the number of exploit in Metasploit DB is something around 200,000. So I'm guessing it very closely mirrors the graph of just oldest. because, I mean, all of them must have gotten hit if 200,000 breaches happened.
Could you help me think through this data from the product vendor standpoint of prioritizing patching, or like actually releasing patches to vulnerabilities? How this data would maybe skew our prioritization versus just using CVSS and the temporal score?
That's a very good question. I think, and Ed will say more to this because he knows security. To me, from a data standpoint, I think it means that if your goal as a vendor is to protect against the things that are being actually breached, tier 1 priority is things that have exploits, and not just things that are in exploit DB, because things in exploit DB are often like proof of concept things that are like, I heard about this on Twitter, so like people are going to hack this. What's more interesting is if there are modules exploiting it. Same thing as the Mendoza line for remediating vulnerabilities. There should be a Mendoza line for publishing patches. So everything that has a Metasploit should also get fixed, right? And then in terms of prioritizing other things, I think that's a question of everybody in the security industry getting more or less real-time breach data and more or less real-time trending data or velocity data for what people are using, because that's a better meter to me of how important something is than calling it a 10 or 9.
I couldn't possibly ask
What about other exploit tools?
that. So there's other things that we've started to
Working
look
on
at, but it's not yet in this data set that you're
Yeah, so we should be looking at black hat exploit kits, definitely. We're going to start doing that. It's hard to do because those people will hack you, but we'll get there eventually. Tim?
With all this data, have you guys ever considered putting a percentage next to each vulnerability of the likelihood of attack? Something that makes it super clear.
I definitely considered it
Nice
2 days
sandbag,
ago.
yeah. You don't get a t-shirt for that.
I definitely considered it 2 days ago when I pulled the data.
Okay.
I hate to bring up the word here, but for those who live in a credit card world where we are told we have to clean the CD.
4 and above, yeah.
Yeah.
Have y'all had discussions?
Which, by the way, if you look at the distribution, is pretty much almost every CVE. But go ahead.
Yeah. Have you started discussions with the council or anything else to really help get that a little better?
Yeah, we haven't yet. We're just now starting to publish some of this data and dig into it, but we're more than happy to
That's
talk
a very
to
good point. PCI
Mr.
is
Russo and others.
I'd love to talk to them when you get to
Absolutely. PCI is essentially telling you just like fix everything from our perspective.
Just like your auditors, your counsel's never gonna change, right? Because what happens when they say, no, it's cool, just fix this, and somebody gets exploited by something less, then they've got why.
Then they've got the version of the release, they have new versions coming out, you can always participate and at least try it. Instead of just complaining.
Sorry, not to make this a PCI discussion.
But
But you should be able to talk to your bank, to your QSA about your risk management and your vulnerability patch management.
I don't know about, I just know they say the standards, the CD.
They use an example, so you should be able to do something like this and still satisfy PCI.
Oh, sure, but at the end of the day, right?
Let me give you a
At the end of the
t-shirt,
day,
you know you brought it up.
at the end of the day, the forensic analyst that you're gonna have to pay for so that they can prove that you are not compliant. Because who's been breached and actually been found compliant? Nobody, right? You're gonna get screwed either way. Right?
And with-
you can do this, maybe this will take some workload, it'll be less onerous for you, but it's not like this is diligent or anything that'll stand up in court compared to the other.
Well, neither is any of the other PCI stuff, like you said, right? You're going to be found compliant when you get breached anyway.
we're
sorry,
getting the
I
hook,
cut down
so I got to cut us off.
conversation.
But if there are more questions or you want to discuss anything, we'll just be right out in the hallway. Pat, the guy over there standing there, also has t-shirts if you want those as well. But thank you very much.
Towel.